Today's lesson is application of vectors. Usually it involves forces acting on an object. All right, number one here says find the magnitude and direction of the resultant vector if V is 43 newtons at 75 degrees and U is 67 newtons at 40 degrees. So really a resultant comes from adding. So I've got to add these two vectors together. But I like to draw a picture real quick. So remember, you start with a horizontal line. You have your initial point. You go 75 degrees, and this is 43 newtons, okay? And this is 75 degrees. At that point, you draw horizontal, and you have 40 degrees. And remember, the initial point starts at the terminal point of the first one, and then you do 67 newtons. And my resultant connects the beginning to the end. So I'm looking for is this angle and the length of that line. Well, remember to put these in component form, you take 43 times the cosine of 75 and add to it 67 times the cosine of 40. And the other component is 43 times the sine of 75 plus 67 times the sine of 40 degrees. And then you just put that in your calculator. So let's see what we got. 43, I'm in degrees, cosine 75 plus 67 cosine 40. And I got 62.454. 43 sine of 75 plus 67 sine of 40, and I get 84.602. So there's my component form to find the magnitude. Remember, we use absolute value signs to represent magnitude. It's the square root of 62.454 squared plus 84.602 squared. So you put it in your calculator. 602 squared. Then you take the square root. And I got 105.157 newtons. Don't forget your units. Direction. My angle is going to be the inverse tan of y over x, so 84.602, 62.454. It's in the first quadrant because these are both positive, so I don't need to worry about adding 180. Inverse tan, 84.602 over 62.454, and I got 53.565 degrees. All there is to it, okay? All right, this one we have to learn a little bit. An airplane is flying due east at 290 miles an hour. Okay, so he's going this way, 290. The wind is blowing due south, so it's coming from the north, blowing south at 40 miles an hour. And you want to find the plane's resultant velocity. So that's going to be from here to here, from where you started to where you ended. Okay, so we already have the component form. Okay, it's um, 290 and negative 40. Magnitude, 290 squared plus 40 squared. You can make it negative if you want. Just remember it's in parentheses then. You shouldn't need to do that. 290 squared plus 40 squared. Shift square root, shift answer. And it told me it's 10 root 857. My angle is the inverse tan, a negative 40 over 290. Since it's in the fourth quadrant, a negative angle is fine. .290, and I got negative 7.853 degrees. Or you can subtract it from 360, and you get 352.147 degrees. Either one works. Okay? So you need to know about your directions. All right, given two forces, one at 37 degrees above due west, one at 29 degrees above due east. Okay? Find the magnitude and direction of the vectors. Be careful about common mistakes here. First place, 37 degrees above due west. So this is going west. 37 degrees is that way. So that's 53 newtons. This is 37 degrees. This one's above due east. So this is going east, right? 29 degrees. And it's 82 newtons. All right, your resultant is not connecting the endpoints. If you had pulling on it, it's going to be going somewhere in the middle, right? Because they're both pulling on the same thing. So if you draw it the way you add, you draw your first one over here, and that's 180 minus 37 degrees, which is 143 degrees. And then at the end of it, you'd measure 29 degrees and draw this. And your resultant connects them right there. Okay? So you're going to do components. The key thing is figuring out this angle. So my components are 53 times the cosine of 143, not 37, plus 82 times the cosine of 29, 53 sine of 143 plus 82 sine of 29. And you put them in your calculator. 53 cosine 143 plus 82 cosine of 29. And I got 29.391. 53 sine of 143 plus 82 sine of 29, and I get 71.651. Magnitude, absolute value signs, 29.391 squared plus 71.651 squared. Take the square root. Squared, and I get 77.445 newtons. This is newtons too. Isn't it right? No, that's miles. Miles per hour. Okay. And then your direction, inverse tan, they're both positive. It should be in the first quadrant. So I don't need to worry about adding 180. Shift tan 71.651, 29.391, and it gives me 67.697 degrees. All right. Both of these are learning things. Make sure you listen and take notes. All right, you have twins. Mo and Joe are pulling a wagon down the street. Mo is so here's my wagon. And there's handle. All right, Mo's pulling with 28 pounds of force. 28, that's Mo. And then Joe's pulling with 36. And they tell us the angle in between the ropes is 43. And you have to figure out the resultant. Well, if they're pulling it down the thing and one's pulling one way, one's pulling this way, it's going to be going like this. He's stronger. All right? So the wagon's going to be going in that direction. So what happens is you pick one of them to draw flat. So I'm going to do Mo because he was listed first. This is 28 pounds. And then you continue your line and you measure this 43 degrees because it's the angle between them. And you draw Joe at 36. my resultant is that. Okay? So the angle for the 28 degrees is 0. You end up with 28 times the cosine of 0 plus 36 times the cosine of 43. And 28 sine of 0 plus 36 sine of 43. You put your calculator. 28 cosine of 0 plus 36 cosine of 43 tells me it's 54.329. And 28 times the sine of 0 should be 0, right? Plus 36 sine of 43 is 24.552. So my result, 54.329 squared plus 24.552 squared, 329 squared plus 24.552 squared. Shift square root, shift answer equals 59.619 pounds of force. All right, if you add them together, you would have had 50, you'd had 64. It's a little bit less because they're pulling on each other. All right, the ropes are pulling on each other, or their hands are, and you're pulling on the wagon. Okay, now to get the direction, you do inverse tan of 24.552 over 54.329. What do I get? 24.552. Can't read my own handwriting. 54.329. And I get 24.319 degrees. And you must state from Joe. Okay? This is important. Don't forget to tell me it's away from Joe. Because you could have drawn this picture the other way and done 36. Okay. Angle. And your resultant would be here. And your force, your angle would then be away from Mo instead of Joe. So it's important to tell me how you drew the picture. Okay? All right. Last problem. A 100-pound box lies on a ramp that makes an angle of 13 degrees with the horizontal. Okay? So here's my horizontal. Here's the ramp. This is 13 degrees. There's a box sitting here. It weighs 100 pounds. All right. A rope is tied to the box from a post at the top of the hill. So here's a post. That rope's holding it. Ignoring friction, how much force is being exerted on the rope at the box? All right, so gravity's pulling down. This is 100 pounds. The components of that vector are this one and this one. This is the force that holds it on the hill. This is the force that's pulling it down the hill. Well, this force and this force have to be the same in order for it to be in equilibrium and not moving. Okay, so now you just have to figure out some angles in that triangle. Well, this is a right triangle. That's 13. That's the force. Hang on. Eek. Okay, that's 100 pounds coming down. This angle's a right angle. So this is 67 degrees. 180 minus 67 gives me, this one's 113. Well, this is a right angle. It's perpendicular to this thing. So you subtract 90, and guess what? Something was wrong. Oh, that's because this should be 77 degrees, right? It has to add up to 90. Okay, let's put that line back in. Here's my box. This is 13. This has to be 77 because it has to add up to 90, right? So that, and you subtract 90, So let's see, what is that? 180 minus 77 tells me this is 103 degrees. And then you subtract 90. And this angle right here God damn it. Sorry, pardon my French, is 13 degrees. Okay? Now I have a right triangle. This is the opposite side. I'm looking for that force. This is the hypotenuse. It's 100. So I know the sine of 13 degrees equals the force I'm looking for over 100. So 100 times the sine of 13. 100 sine of 13 is 22.495 pounds. That's what's holding it on the force. Okay. Here's the thing. This is 27 degrees. My box is sitting here. It's got a force that comes down. This is the component of my force. This angle is 27 degrees every time. And this is the weight of the box. Okay? Go practice.